Quantum computing. It sounds like something out of a sci-fi movie, right? Like a robot's brain or that thing that powers time travel. But no, it's real. And it might just change everything we know about technology. So what's the big deal with quantum computing? Buckle up, because we're about to break it down without breaking your brains. Alright, let's hop in a time machine and go back to the early 1900s. Back then, physicists started to realize that the world of tiny particles, atoms and stuffs, was, well, weird. Particles didn't behave like the objects we saw every day. Things could be in two places at the same time, and that wasn't even the strangest part. Fast forward to the 1980s, where physicist Richard Feynman had an epiphany. He thought, if nature itself is so weird, why don't we make a computer that is just as weird? And boom, quantum computing was born. Well, at least the idea of it. They didn't build one in the 1980s because, well, computers back then were basically the size of refrigerators and could basically play a decent game of Pac-Man. By the 90s, scientists were starting to come up with actual algorithms for quantum computers. Enter Shor's algorithm, which sounds fancy, but it basically means that quantum computers could solve huge math problems that classical computers would take forever to solve.
Huh?
Seriously, classical computers would be like,
Sorry, come back in a million years.
while quantum computers would be like,
Got it down, next.
alright, so how do quantum computers work, and why do they sound like wizardry? It all comes down to two key concepts, qubits and quantum weirdness. Classical computers uses bits, and these bits are like switches, either ones or zeros, on or off. It's like deciding whether you want a pizza or a salad, two things that are kind of similar but yet very opposite. While quantum computer on the other hand, they are more like, why not both? And this is called superposition. A qubit can be 1, 0 or both at the same time. Imagine trying to make a decision and instead of picking one, you just pick all of them. That's superposition. Next is entanglement, which is when qubits get so close that they start finishing each other's sentences. It's like a spooky connection between qubits, where if you change one, the other one changes instantaneously, no matter how far apart they are. It's the ultimate long distance relationship that seems not to work with you and your girlfriend. Albert Einstein actually called it spooky actions at a distance, which is basically his way of saying, I don't get it either, but it works. So thanks to superposition and entanglements, quantum computers can process multiple calculations at once, while a classical computer solves problems one step at a time, like a student showing their workings in a math class. Quantum computers are like, nah, I skipped ahead to the answer, which, let's be honest, we all wish that we could do that in school. So what can quantum computers actually do? Well, imagine if a doctor could simulate every possible way a drug interacts with your body in a second. That's the dream for medicine. Or what if your online passwords were completely unbreakable? And that's where quantum cryptography comes in. Because let's face it, password 123 isn't cutting it anymore. But here's the catch, building these bad boys is hard. Quantum computers need to be super code, like colder than space code, to keep qubits from getting all worked up. And scaling them up, yeah, that's like building a tower of cards in a windy tunnel, very delicate work. Still, companies like IBM, Google and Microsoft are all racing to crack the code and make large-scale quantum computers a reality. It's like the Olympics of quantum, but instead of gold medals, the prize is, monopolizing the world. So in a nutshell, quantum computers are the weird cousin of classical computers. Using quantum computers to process information is a totally new way. It's very complicated, it's amazing, and it's just getting started. Will a quantum computer change the world? Probably. Will it also break your brain a little? Definitely. If you enjoyed this video and you want more of tech and science related ones, like, subscribe and comment below. See you in the future, or in the past, or both at the same time. Because, quantum. Thanks for watching.